Hi student, hello, good evening. So today we are going to see the question number 72. Okay, so this is my question number 72. ISRO 2018. Okay, ISRO 2018. Question number 60. Question number 72. So this is my question number 72. Okay, so question number 72 is about for the negative feedback, for the negative unity feedback system. Gain is given as negative unity feedback system. So this is my negative unity feedback system for which the gain is given as g of s is equal to 0.25. 0.25 divided by s square plus 1 into 8s plus 3. Okay, so this is what unity feedback system. Okay, for a unity feedback system, this is my g of s that is given, means it is connected with what? Unity feedback system. So unity feedback system, so this is my g of s here, g of s, and is connected with unity feedback, negative feedback. Okay, so this is my unity feedback. Now, he is asking the transfer function of the lead compensator aimed at achieving gain crossover frequency of 0.5 radian per second, and gain crossover frequency is 0.5 radian per second. Okay, and phase margin is what? Phase margin is about 30 degrees. So then he is asking for compensator. Which compensator? Lead compensator. This is condition for lead compensator. Lead compensator. Lead compensator. Okay. So which compensator we should use so that we will achieve this condition. Okay. So we will achieve this. So for unity feedback system, transfer function of the lead compensator aimed at gain crossover frequency, aimed at achieving gain crossover frequency 0.5 radian per second, and phase margin is 30 degree. Which of the following transfer function is correct? So first of all, we should know about lead compensator. What? Lead compensator. See, lead compensator. What is this lead compensator? If you see, the lead compensator is nothing but, as you know very well, compensator is nothing but, compensator is what? Compensator is used to make the system proper. If the system is not proper, means there whatever the parameter that is present within the system, if these parameters are not in the range of what? Not in proper range, so then in that case we are using what? Compensator. So it will make the system proper. Okay, so this lead compensator is nothing but a type of compensator. Okay, so type of compensator, this is like zero pole. Okay, so lead compensator is a type of type of system whose pole is whose, okay, so which has zero near to the origin. Zero is near to the origin, and this type of system is what? Lead compensator. It always give the lead compensator, so it is a leading compensator. Okay, so like you can see high pass filter, lead compensator. So now, if you see the option A is not at all. See option A and C, B. So if you see option B, unstable. Okay, so first of all, see unstable. If you see option number A, so lead lag compensator. So this is like for lead lag compensator, H of s is equal to s plus A divided by s plus B. Okay, so where B must be greater than A. Okay, so this is the condition for lead compensator. If you see the option A is what? A is nothing but here. A is 1 by 2 root 3, and B is, and here B is how much? B is root 3 by 2. Yes, root 3 by 2. If you see B is greater than what? B is greater than what? A. So this satisfies the lead compensator. Yes, it satisfies lead compensator condition. Okay, So we will take in consideration this one. And b, if we see for b, b is what, root 3, s minus 1. So b is what, unstable. So b is unstable, we will not take into the consideration. Okay, so because b1 is unstable, because pole and 0 both are, pole and 0 both are lying in right half of the s plane. Okay, so as we know very well, the system which has the pole in the right half of the right half of the half of the s plane, then that system is what, unstable system. That system is unstable system which has pole on the right half of the s plane. So next, if you see c, option c, option c has what, option c. So this is unstable, so we will not take into the consideration. Option b, option c is what, if you see for c, the pole is at what, pole a. So a value is nothing but it is 1 by root 1 by 2 root 3, again 2 root 3, and b is how much? Here b is nothing but root 3 by 2, similar to a. This is similar to a. Here also b is greater than a. So it satisfies the condition of what, lead compensator. Lead compensator. If you see option D, option D. So let's say option D is what? Is it visible? Yes, somewhat. Option D is nothing but, if you see a value here, a is nothing but, what is a? A is root 3. So a value is 2 root 3, 2 root 3. A value is 2 root 3 and b is nothing but root 3 by 2. Root 3 by 2. So therefore here b is less than a. So it will not satisfy, what, lead compensator condition. So therefore D we will not take into consideration. So B and D we should not take into the consideration, because B is what, unstable, because pole is lying on the right half of the S plane. And if you see the D is what, D is not satisfying what, lead compensator, but D is what, it is a lag compensator. Okay, so now we will take only consideration A and C. Okay, so now see here, A and C. So now we are confirmed about lead compensator. Okay, so only either option A is correct, either option C is correct. Okay, C is correct. So in option A and option C, if you see from option A, omega GC. For this omega GC is given as how much? 0.5 radian per second. 0.5 radian per second. As we know very well, omega GC is nothing but it is the gain crossover frequency at which the magnitude of the gain becomes unity. At which the magnitude of the gain is unity. It is a gain crossover frequency. So magnitude is unity means what? If you see for lead compensator, G of S is equal to for option A, that is 5 into root 3 s plus 0.5 divided by s plus 0.5 root 3 root 3. If you see omega GC, okay, so omega GC is how much? If you will see here, omega GC is nothing but here magnitude at omega GC, that must be equal to unity. Okay, at omega GC. So which is nothing but, if you see here 5, this is square root of root 3 means 3 omega GC square plus 0.25, and this is divided by here omega GC square plus this is root 3 3 into 0.5 3. Okay, so 3 divided by 4 means it is 0.75. Now if we will put what omega gc is equal to point 5, what you will get from here? This is 5. This is square root of omega gc is 5. So this is 75. Okay. So if it is zero point 0.5, so it is 0.75 plus 0.25 divided by here also it is 0.25. Okay, it is 0.25 plus this is 0.75, so which is nothing but 5. So it is not coming, what it is not coming unity, so this means what option A is wrong, option A is not correct, so only the option C is left, so it is correct because only option is C is left. So let's see, we will check it in also. Okay, so here gain crossover frequency, here the magnitude is coming 5, so that's why this option is wrong, option is wrong. So now see here for option C, option C, for option C is nothing but it is just GC of S. GC of S is nothing but, so this is root 3s plus zero point 0.5 divided by s plus 0.5 root 3 s plus 0.5 root 3. Okay, so now if we see here this g of gc of omega gc is equal to root 3. Okay, so just root 3 j omega gc plus 0.5 divided by j omega gc plus 0.5 root 3. Okay, so now if we take what magnitude g of omega gc, how much it will come? See here, square root of 3 plus 3 omega gc square plus 0.25 divided by how much? Omega gc square plus 3 by 4 means 0.75. Now you just put omega gc is equal to how much? That is given as 0.5 radian per second. How much we will get here? So this is nothing but 0.25. It's the 0.75 plus 0.25 divided by this is 0.25 plus 0.75. Okay, so this will get cancelled and we are getting what? Omega gc. We are getting what? We are getting g of j omega gc magnitude is equal to what? 1 is equal to 1 at what? At omega gc is equal to 0.5 radian 0.5 radian per second. Okay, 0.5 radian per second. We are getting magnitude is equal to 1. So this means what? This means it is a gain crossover frequency. Okay, so where we are getting the magnitude is equal to what? 1 is equal to 1, and this is also a what? Lead compensator. This is lead compensator because B is what? Because here B is coming greater than A. Okay, so this is lead compensator. B means what? Here 0. Here pole is greater than what? Pole is greater than 0. Okay, pole is greater than 0 means lead compensator. If 0 is greater than pole means it is a lag compensator. What? Lag compensator. So this is what, hence we can say that option C is correct. Option C is correct. Option C is correct and every. Okay, so this is what option C is correct. So now we are confirmed now. Okay, so lead compensator which has magnitude is equal to 1 is at omega gc is equal to 0.5 radian per second, and we can also check for phase margin. Yes, phase margin is nothing but what? Phase margin is equal to 180 degree plus angle g of omega gc. Okay, so from here we can calculate angle of g of omega gc is how much? If you will see, that is minus 150 degree. So this is angle g of omega gc. Okay, so you can get this from this. Okay, so at omega gc is equal to 0.5, we will get minus 150 degree of angle g of omega gc, and it will give us phase margin of 30 degree. Hence option C is correct. So this is my lead compensator. Which will give what? which will give gain crossover frequency of 0.5 radian per second and a phase margin of 30 degrees. Okay, so that's all about this question number 72. Now see the question number 73. What question number 73? So question number 73 is about what is sensitivity of transfer function. It is about sensitivity. Sensitivity. So see here question number 73. Question number 73. It is about sensitivity. A sensitivity of transfer function is given as a sensitivity of transfer function that is given as a1. What a1 plus ka2 divided by ka2 divided by a3 plus ka4. So this is my transfer function, and he is asking about what the sensitivity of this transfer function with respect to k. With respect to k is given as what? Sensitivity. What? See here, sensitivity of what? Transfer function. With respect to what? With respect to k. Okay, sensitivity of transfer function with respect to k is nothing but that is dou t by t divided by dou k by k. So this is my sensitivity, rate of change of transfer function. Okay, so this is what dou t by t. So now we can write this as sk to t is equal to what? Dou is equal to k by t. What? K by t into dou t by dou k. Okay, so dou t by dou k. So if you see this k, how much is t? T is this, and it will come upside. So this is nothing but a3 plus ka4 divided by how much? a1 plus ka2, and this is what? Dou by dou k of what? This transfer function. How much? a1 plus ka2 divided by a3 plus ka4. So now we have to differentiate this factor with respect to k. What we are going to get? If you see here, this is my sk2t. This is sensitivity factor. So this is nothing but k into a3 plus a4 divided by, this is my a1 plus ka2. So into differentiation. Okay, so this is what? Denominator. Okay, so if you see this differentiation of this numerator to denominator is nothing but denominator square a3 plus ka4 whole square. Now you see here a3 plus ka4 into differentiation of this numerator, that we will get into a2 minus this is my a1 plus ka2 into differentiation of denominator, that is nothing but a4. Yes, now see here what we will get from here. sk2t. Yes, sensitivity of transfer function with respect to k is equal to what? K into a3 plus ka4 divided by a1 plus ka2 a1 plus ka2 into a3 a2. Okay, so this is my a3 a2 plus ka2 a4 minus a1 a4 minus ka2 a4 divided by how much? a3 plus ka4 whole square. Now this will get cancelled. Yes, ka2 a4 minus ka2 a4. So now see here, this also will get cancelled. So this factor. Now we are left with what? If you see how much space is there. So only one line of space is there. We will get sk to t. Sk to t is how much? Sk to t is nothing but k into a3 a2 means a2 a3 a2 a3 minus a1 a4 a1 a4 divided by a1 a4 divided by a1 a1 plus ka2 a1 plus ka2 ka2 into a3 plus ka4 ka4. Okay, so this is what k into a2 a3 minus a1 a4 divided by a1. This is a1 plus, okay, so this is my a1 plus ka2 into a3 plus ka4. Okay, so this is final answer. What? K into a2 a3 a3 minus a1 a4 a4 divided by a1 a1 plus ka2 ka2 into a3 plus ka4 ka4. Hence, if you will match the option, so this is nothing but ka2 a3 minus a1 a4 divided by a3 plus ka4 into a1 plus ka2. Hence, option A is correct. For this, option A is correct. So nothing is there for sensitivity. As we know very well, sensitivity k to t is nothing but 2t by t divided by 2k by k. Percentage change in transfer function with respect to percentage change in what factor, or you can say feedback factor. Okay, so this is overall what sensitivity of transfer function with respect to parameter k. So just there is a basic concept for what? For differentiation. So that is uh, numerator to denominator. When we differentiate this type of term, always take the square of denominator, and after that denominator remains same. Differentiation of numerator minus denominator minus numerator same. Differentiation of denominator. Okay, so this is all about this, and we have got this answer, and it is matching with option A, and hence question number 73, the option is correct. Okay, so that's all for today. Okay, so thank you very much. Okay.